Welcome to this lecture series on computer architecture. So today's class we will learn about the data path construction, step-by-step procedure in constructing data path for MIPS, building up data path for MIPS architecture. That is microprocessor without interlocked pipeline stages. Okay, so this course is handled by Dr. K. Balasubhadra and Dr. Prasanna Srinivasan. And the sources for this PPT or this video lecture is taken from Morgan Kaufman and one more source from cs.ait.ac.th for better understanding of the data path. Right, so the task is for building the data path for MIPS processor. So first of all, we need to understand the corresponding general components of the computer. So with respect to the MIPS, the processor, that is CPU, is divided into two. That is, one is control and then data path. So this is the two main components or composition of the CPU, right? And then we know that separate instruction and memory and data memory is available for MIPS architecture, and the control or the processor is going to fetch the instruction from the instruction memory. So it is from the memory to the processor. So that is why the arrow mark is towards the processor. And if you see in the data memory, the processor is for processing the operands, okay, to execute the instruction and perform the necessary operation. The processor needs data, okay, so that is taken from the data memory. So, and also after the processing, the result also should be stored in the data memory. That is why two-way, okay, so from the data path to the data memory and from data memory to the processor, right? Right, this illustrates a key idea for building up the data path. So how the communication should be built, okay, communication between different functional elements to be built, okay, so that the necessary instructions are being executed successfully. So we know that in MIPS there are different categories of instructions. For normal arithmetic operation and logical operations, we have several addition, ADD, SUB, AND, OR, like that. SLT is for shift left. Then memory reference instructions are there, like load word and store word, and control flow instructions are jump and BEQ. Okay, BNE is also there. For our example, we are going to see with a few sets of instruction, and then we are going to build the data path for all the instructions with respect to the MIPS. Okay, for these things to be implemented, we need 5 steps. The 5-step process for instruction execution is, the first step is the instruction fetch. The process should first fetch the instruction, and the reference for fetching the instruction, where the instruction is available in the memory. Okay, so the reading where the processor should read the instruction, so that particular memory location, address of that location is specified with respect to the program counter. So the program counter will hold the address of the next instruction to be executed by the processor. Okay, so once the instruction is fetched, okay, then the process should understand what it should do. That step we call it as decoding. Okay, right, decoding, right. Then the third step is execution, where the real execution is performed with respect to the ALU or whatever type of instruction. It depends on the type of instruction, right? So the exact operation is performed. And then next fourth step is, with respect to the data memory access, we need some memory reference. Okay, that memory reference instructions are load word or store word. Okay, so this is memory reference. And then finally write back. Write back is the values obtained during the course of execution. Okay, that value is written back to the registers. So this is the 5-step execution process which we will be following in the MIPS processor architecture. So here we are going to consider a very simple implementation of MIPS, that is single cycle implementation, where single cycle implementation means the MIPS will use a single long clock cycle for every instruction. Okay, so every instruction will be begin with respect to one clock edge, and it will be completing in the next clock edge. Okay, so that is the implementation scenario we consider, and this approach is not practical. okay, because it will be much slower than multi-cycle operation, where in multi-cycle different instruction classes can take different number of cycles. Okay, so in a single cycle implementation, every instruction must take same amount of time as the slowest instruction. Whichever instruction in the entire instruction set takes slowest, okay, slowest cycle, okay, that is largest cycle, sorry, largest cycle. So all the remaining instruction also will be having the same cycle, okay, as that of that particular instruction which takes longest time for execution. Okay, so in multi-cycle the scenario is different. This problem is avoided by allowing quicker instruction to use fewer cycles. So whichever instruction is going to use fewer cycles, they can be completing in the lesser number of cycles. So that is a multi-cycle implementation. But even though the single cycle approach is not practical, it is simple and useful for understanding the concept. So we are taking up the single cycle implementation first. So the first step in building the data path in MIPS is step one is instruction fetch. For fetching the instruction, we need two important functional unit. One is called as program counter and the instruction memory. The program counter is going to hold the address of the next instruction to be executed. If you see this is the flow of instruction. Okay, so you think that the processor is currently executing this add instruction, and when it is this instruction is fetched and it is in the decoding process, the PC is already incremented. Okay, PC is equal to PC plus 4. Okay, why it is PC equal to PC plus 4? In the sense, because the MIPS processor is going to follow the byte addressing. What is byte addressing? So only for that is in each location of the memory we will be having only one byte of information. Okay, so MIPS, you know, both instruction and data is represented in 32 bits. It is a 32-bit processor. Okay, it can handle 32-bit data at any time. Okay, that is why we say it as 32-bit processor. So to have the entire 32-bit, we need to traverse in the memory location 4 locations. Okay, the first location we will have for first 8-bit, second 8-bit, third 8-bit. In the fourth location we will have the last 8-bit. So we need to traverse 4 locations of byte addressing, so that we will get the entire 32-bit information. So that is PC is equal to PC plus 4. So the PC will be holding this memory location, this address. Okay, so that for once the next instruction is decoded, it will be incremented to PC is equal to PC plus 4. So this is the process, right? Now one more addition we add, because we need to add 4, we need this adder. Okay, so this adder is included in the functional unit. So the PC is there, program counter, which will be holding the address of the next instruction for execution, right? Once the processor, once the PC is accessed by the processor and it is fetched the instruction, the PC will be incremented by 4. So the PC will hold the next byte. Okay, the next 32-bit where the corresponding execution should start. Location of that next instruction, right? Right. This is the 32-bit adder. Okay, so the whatever the PC content is there, this processor will look into the instruction memory with that particular location address and it will fetch the instruction. So this is how the data path, the functional unit is implemented. Okay, and the connections are given to each unit, so that to perform the PC is equal to PC plus 4 and as well as the instruction fetch from the instruction memory. So this is the important functional unit. Now we will see the animated data path. Okay, for this instruction fetch. So first step, processor is getting the memory location from the program counter. So it is highlighted by this green transition, right? Right, that address is located or indexed into the instruction memory. Okay, so instruction memory, once that location, whatever the instruction is there in that particular location, it will be fetched. Okay, so meantime what will happen, this PC content is given to this adder, one input of this adder. Okay, and also we are adding 4. PC is equal to PC plus 4. It is added and it is again restored back to the PC. So now the PC will be incremented and the PC is equal to PC plus 4 value is available in the PC. It is ready now. Okay, so that the processor, after completing the current execution, it will go back to the PC and fetch the new instruction. Okay, so this is the step for instruction fetch. So in the next subsequent lecture, we will move on to the corresponding Next available functional units.